So yeah, this is an idea that has been living for a long time, and we finally get to do it. So Cyrille Martraire is CTO at Arolla, and Eric Evans is the author of the first domain-driven design book. About 17, 18 years almost, I think. Well, let's not make ourselves feel old. All right, so I'll give the word to you. If there's anything, you can use the whiteboard, the Miro board, of course. And I should mention that the event stays open for the next 2 days. So if you want to do open space sessions at night or just hang out or play games, it's all fine. So see you in the open space later. Cyrille, over to you.
Yes. So hello, Eric.
Hello, Cyrille.
Oh, yeah. We have to start with something like that.
Yes.
Then I think we need to know absolutely, are you more into Lady Gaga or Diana Ross?
Diana, I'm more into Lady Gaga than Diana Ross, I would say, yes.
Okay. Okay. Maybe you like both?
Because you wanted to know why. I don't think I could say why, except I think Diana Ross was I don't know. It's been a long time. I would say definitively that when Diana Ross's music was current, I was more into Diana Ross than into Lady Gaga, who was perhaps at the time born. I don't know. But now I would say Lady Gaga, yes.
Okay, thanks. So now we can move on. You know, the domain-driven design is almost 18, so which in many countries, like in France, it means you're an adult now. That's the age of majority. And so I think it's time to come back to the children years of domain-driven design and the influences behind it, starting maybe with the obvious things, programming languages. I remember you told me a long time ago about Smalltalk. That has Smalltalk something to do with domain-driven design?
Well, it isn't an extremely... That isn't to say that Smalltalk produced domain-driven design as such, but I think what was important was, I think a few things. Above all, the community that grew up around Smalltalk, which is probably part of what drew me into the language too, was a very model-oriented community, right? That community cared about modeling, cared about design, and they had this idea that there would be a model of the domain and that it would be represented very explicitly in the software. And of course, also Smalltalk is a nice language. I think another idea that was fairly common in the Smalltalk world was that the programming language could be used to create a kind of expression of the language people use to talk about the domain. So you would create this, I'm going to use terminology that came later, like a domain-specific language in the programming language, or I think what Martin Fowler dubbed a internal domain-specific language. So this idea emerged out of that community, I think. I'm sure it may have existed elsewhere as well, but that's where it came to me, right? And
so you've been one of the early adopters of Smalltalk in the companies you were working for?
Yes, that is true. I am not what you would call an early adopter of Smalltalk, I suppose, because, when I first started with Smalltalk, well, using it professionally, I think would have been 1990, by which time Smalltalk was, had been around for a while, but it was only beginning to be used in commercial situations, right? Only beginning to be used in a larger scale. And it had a few years where it looked like it might be a big language. It's a big influential language, but it isn't a big.
I see many people reacting on the chat with mention of Smalltalk. Like you have a lot of fans of Smalltalk around here in this conference.
There should be fans of Smalltalk. You know, there are languages that we actually use to build things, and then there are languages that, even if we don't, we should learn them to learn from them, you know. I think Smalltalk is one of those languages. I used to say to people who were working on C++ projects, and I don't, C++ is a language that never spoke to me. I have never been in a serious C++ project because it just doesn't work for me. But it was for a while a very important language for OO. And I used to say, if you want to learn to do C++ well, you should go learn Smalltalk.
Was it easy to integrate your Smalltalk project with the C++ people around?
No, it was approximately impossible to integrate. This, by the way, you know, in long hindsight, I've mentioned this before. I think that the importance of bounded context is another thing that might be very indirectly related to Smalltalk, because when I was reflecting on why we had so much success in those days, I concluded that it wasn't just the language, though it is a very nice language. And it wasn't even just the people, although the thing is that that language tended to draw to the project a certain kind of person. It's very strong on design and interested in the domain and so on. So it did help you get the right team together. But the other thing it did was it made integration utterly painful, bordering on impossible. And in hindsight, I realized that this created a boundary around the thing you were building that allowed you to have a very clear and distinct model. Something that didn't just casually, you know, in a modern software system in most languages, because this, of course, we think of as a good thing. Boundary for the win.
For the win.
We think of it as a good thing that it's very easy to integrate with any kind of tool or any kind of other system. And I see that that is powerful. But what it means is that in a few lines of code, I can get through any boundary. And I think that the lack of any friction there makes it much harder then. And I think that, as you know, as most people will know, I think that a necessary prerequisite for a good domain model or a good, you know, piece of software based on a domain model is a really sharp and clear boundary that, you know, we call the bounded context. And that's a lot harder in a system that has these powerful integration technologies.
So actually, the bounded context part of it, the bounded part, you experienced it as part of this team, an island of Smalltalk within an ocean of C++, and this autonomy, you felt the benefits of it, and it may have been some part in the idea behind the bounded part of a bounded context.
I think it contributed very much because it'll, and not to mention that it allowed me to experience what it would be like to be in a bounded context. I can't tell you how many people I've talked to who say, I've never experienced a really good project like the ones you described in the book or the ones that I talked about in some of my talks. And I think that's a shame, but I think probably the biggest reason is that most people haven't ever been in a really bounded context. You know, they're in these systems that just kind of blend into each other. This thing calls that thing, calls that thing, calls that thing. And so that's why I think, I don't know, but of course all this.
No, but we want to understand, actually, personally, I'm very curious to look at where does the DDD come from, all the influences, etc. In your book, you mentioned multiple influences as well, like borrowing from other programming languages like Lisp, Prolog, SQL being mentioned as some of the styles that we could borrow to do some modeling. these were programming languages you used to practice a little bit, or you had some exposure with? Maybe
Well,
MATLAB as well?
So everyone ends up using SQL, and I did too. And so I used SQL when we were writing by hand. I mean, of course, the book was written in the early 2000s or the late, so that was a different era than the one we were talking about a few minutes ago. And I had spent the previous few years working on Java projects mostly. And these Java projects generally had some form of, object relational mapping technology. And before that, we would write, including the horrific EJBs. And before that, we would write some of these things by hand, and we'd write a piece of SQL and a piece of code that would turn the response of the SQL into objects. And then came various object mapping. And the EJBs were just a disaster. They undermined everything that was good about objects. And people did start to set them aside. Even by 2000, people were saying, we can write Java without EJBs and use different ORMs. Now, I would even say that ORMs themselves are problematic. I'll explain why I think that. But the thing that your question was really about, how do these other things influence?
Yes, the different styles, paradigms, Prolog. We can, when in the book, when you in some patterns, they feel a bit like Lisp-ish or Prolog-ish or some.
Yeah, I don't think that I agree that does have that feel, but I agree with that in hindsight. I don't think that was the actual way that sense came to me, because when I wrote the book, my knowledge of Lisp was very limited. I've actually, gotten much more interested in it by way of Clojure several years ago, as some people know, and I did make some presentations.
Which means right now, right?
What?
Which means right now. You are in Clojure right now?
I am in Clojure. Oh, well, I would be if I weren't in this thing. No. But yeah, I really enjoyed Clojure a lot and learned a lot from it, which is to say from, Lisp. But I had encountered Lisp, but hadn't liked it before that. I think for various reasons that I could explain. But when I think about where did that feeling that you got come from, I'm just saying I don't think it came from Lisp, because I didn't have that exposure at the time. I think it might have come from some, we underestimate, people like these very clear boundaries. And so we say, oh, the OO world had this way of doing things, and the functional world had this way of doing things. But I don't think it was that clear cut. And I think some of those concepts did exist in the OO world, but not as strong. Like the idea that you would have very clearly defined functions that did transformations. I think it was a common pattern, for example, that an object would have a method that would return another object that was basically a transformed version of the first object. This was a common kind of pattern in Smalltalk. And it's basically pretty functional, And then another thing that people might not realize is that my degree, I didn't actually study computer science in college. So I had a math and physics undergraduate degree and an engineering master's degree. So I suppose that the math, wow, he says. So I suppose that if you think, well, where would the functional perspective come from? It might have come from being a math major. I don't, of course, I can't know these things. I reflect on, where did this or that come from? I'm probably more self-aware now than I was when I actually wrote the book. But monoids, yes. So
Matt,
now monoids is an interesting.
Please carry on. Please carry on.
No, monoids. See, this is a point where, there were things that I wrote about, and then you, Cyrille, you took some of these things and actually drew them out more strongly and clearly. And so I had written in my book, when I was trying to describe the kinds of models that I really like, there's a chapter in the book, which I think is one of my better chapters, but it's too late in the book for anyone to have read. But if someone wants to skip ahead past the place where people usually stop, there's a chapter called Supple Design, where I tried to describe what kind of software I really liked. And I had several patterns in that chapter, and they weren't really meant to be a definitive set of patterns for supple design. They were meant to sort of convey, examples, like what kind of characteristics tend to make something have this quality that I call supple. And for the languagey people, by the way, yeah, so one of the things I mentioned in there was closure of operations, which is a mathematical principle. And I didn't, this was a thing, I learned, I guess, because I was a math major. So it's just a thing that makes an algebra or some other kind of mathematical thing nice. And I noticed that we used it sometimes when we were programming. And when we did, the function involved tended to be nice to use. And so I said, there are these principles like closure of operations that we could apply more intentionally. Now, Cyrille, you then said, well, the whole concept of a monoid is actually probably the concept we want to apply. And then made that presentation at DDD Exchange years and years ago. And that was quite exciting to see it like, yeah, that is really what I was going for. Not just, closure of operations by itself is nice, but put it all together into a monoid. That's nicer.
Okay, we'll stop there because it's not about me, it's about you. So you like monoids. I just want to hear that.
You like contradict you because I think one of the important things that happened with DDD, this was not an accident. We worked hard to make it happen, but was that it wasn't just me, and that at an early enough stage, other creative people started to get involved and take it beyond what was in the book. One of those people, for example, was you with monoids and some other things. And Greg Young was one of those early people with event sourcing. And the trouble with naming specifics is that I will miss people. The point is there were a handful of people who came in and started to say, we can do things with this. We don't have to be confined by the things that happen to be mentioned in this book. And I think that's why we are talking about DDD in 2021, because it wasn't stuck in the exact mindset I had in 2004 when the book was published, right? It was able to grow and evolve and reach out beyond one person and one time period.
Talking about the book, actually, you didn't mention everything in the book, and some tune, I think, notice that you don't mention the importance of coffee machines and water coolers within the blue book. How is that? It should be there.
You're going to have to explain what you mean to me. Coffee machines.
The conversation, the communication. Yeah.
So that is an ironic thing to be discussing here in a virtual conference where we are talking over a video that had to be arranged meticulously in advance, and any kind of side conversation I might have with any of the participants of the conference will have to be carefully arranged, because there's no way for us to just walk off the stage when we're done and just kind of happen to meet someone. And that is one of the things about a virtual event, that of course this is one of the most well-planned virtual events I've participated in. Well, it's probably the most well-planned virtual event I've participated in so far, but it still isn't the same as being there in person.
Mm-hmm.
And the same thing happens when you have a office place. Yeah, and you talk to people and you get to know people.
Yeah, but the organizers are taking a lot of care to create that as well during this event. So there's a lot of things to happen around the event. Just a shout out. Look at all the extra things around. Coming back to the origin of DDD, of the influence of it, and so I think who were the people that you would credit as maybe some influences or mentors that helped make the book a reality, or find some way into the book? For instance, you quote some patterns from other people.
Yeah, well, I mean, there were people who were tremendously influential on me. And also, one thing I will say is I know there were influences that I wasn't directly aware of, right? There are people out there right now, I would like to think, who are being influenced by DDD, who have never actually heard of DDD or don't really know what it is. And yet they might be, aware that there's something that they should use value objects or bounded context or something. So the same surely happened with me, but the influences that I'm aware of,
Names?
There were a handful of people. I used to read this column that Kent Beck wrote in this little newsletter that I subscribed to, the Small Talk Report. And so surely that was an influence on me. And then I've mentioned that Rebecca Werfsbach's book, I never met her before the book, but I did read her book. And the concept, remember that responsibility-driven design as a concept was very current and influential. The idea that an object would have certain responsibilities, and that that would be the concept behind the object, and then you try to make everything that was in the object, all the fields and methods and so on, all those things would be in service of this of fulfilling this responsibility. So it's a way of thinking about an object beyond just the actual concrete properties it has. And so not only, and I think it's probably obvious, but just to make it explicit, that is also where the book, where the name comes from, because I liked responsibility-driven design, and I thought, but what I'm talking about is driving the design from something broader, from the domain of the business or technical area or whatever the domain is, letting that drive the design. And so I called it domain-driven design, in no small part because I liked responsibility-driven design, and I was referring, making a reference to that.
The XDD, so it's like a quotation.
I maybe would do it a different way now, because all of a sudden then everything was something DD, and that I must, other people must have been picking up on that pattern at the same time, and I might have accelerated it myself, of course, and by making it one of the first XDDs, and so
Rebecca is reacting right now. She's there. Rebecca is watching, she's watching, and she's reacting like nothing about RDD or conflicts with DDD. Yeah, sure. And she says, XDD meme is one of my unintentional impacts. She says.
Well, I'm glad that Rebecca is here. That's very nice. And I am not driven anymore. She's yeah.
Yeah, I remember you mentioned Ralph Johnson some time ago. Ralph Johnson, because DDD, I'm not sure everyone knows that, but DDD, if you look deep into the internet, you may find that some early paper about DDD was as part of the PLOP, the pattern conference.
Yes, I definitely. Ron Johnson, let's see now, when would he have become aware of it? I think he must have only become aware of it when I submitted it to Plop. So there was a friend of mine, Josh Karievsky, who we were colleagues at some project and friends, and we were both writing stuff at the same time. And we started, I want to get to Ron Johnson because he helped me a lot. But how I ended up at Plop was that Josh and I were we would meet up and just write together and then read what each other wrote and stuff. We were trying to help each other get our writing projects moved along. It was tremendously helpful. And then he ended up being one of my, let's call it Plop, the person that, Shepherd, yeah.
At PLOP.
So, for example, the whole thing where I actually said, okay, I'm going to just use the Alexander format of the patterns in my book, where there's a little picture and and blah blah blah, therefore blah blah blah, and all that. I think that might have been Josh's idea. At least he was strongly encouraged and helped me kind of get it together. So, and in any case, so we were working on that, and that's probably a lot of. Of course, I had gone to Plop before with the specifications pattern paper, which I wrote with Martin Fowler. But then when I wrote these patterns about modeling and design, which wasn't at the time called domain-driven design, I hadn't come up with that name yet. And by then it had split into two parts. So there was this one called Constructing the Domain, and one which later was the strategic design stuff about context and that, which I called Deconstructing the Domain. And these two papers I submitted. And Ron Johnson said that he wanted them in his, he led one of those tracks.
Actually, you mean Ralph Johnson. When you say, you mean Ralph Johnson, right?
Ralph Johnson. What did I say?
We were heard Rod, but Rod is the spring guy. No.
Yeah, I'm sorry, that's a slip of the tongue. Of course, Ralph Johnson.
Ralph, yeah.
All the way through this, I meant Ralph Johnson. Boy, I hope I didn't say that too many times. So, boy, you get old.
No. Ralph.
Yeah, you probably will. But anyway, so Ralph said he wanted both of my papers in his track. And he actually bent the rules of Plop a bit, because it was supposed to be one paper per track. And they were longish papers to begin with. So we did that, and that meant half the track was devoted to me, which was, but the thing is that kind of catapulted me to the next level. The input that I got at Plop was tremendously useful. That conference still exists, I think, and it certainly was a tremendous writers' conference. It was so useful to go there and have all those people help you see what you're doing and have all those useful inputs. And then after that, though, Ralph basically guided me through the whole thing. I mean, after that, he again reviewed the paper with this reading group that he had at University of Illinois, and they went over it. That was actually all done from a distance. It would seem very 2020 because they had these meetings and they recorded them and they just sent me MP3s of their discussion, chapter by chapter by chapter. This was like a couple years later when it was becoming a real draft of a book. And those were excruciating. I was glad to have it on a recording because I could listen for like 10 minutes and then pause it and then go get a drink or something, because it was like awfully hard to hear because they were not gentle. You know, they're from that academic world where people are brutal. You think that people say mean things in our world. Oh, I see in the chat that at some point I said Don Johnson, who's the actor. Oh, good grief. Okay.
Okay, but
I'm
so you mean
type into the chat here. Wow.
So you mean in the chat, Joseph Yoder and Rebecca are reacting, completing as well, because they were there and they're still there. The conference still exists and they're still active. There's one in Europe. There are more than one in Europe, by the way. There's a Viking conference as well, I guess.
There were at least those two big plops and then some many ones too. But the only one I ever went to was the one in Illinois, and it was really a wonderful experience. And one of the things that's interesting about it, you know, I don't know if people know, but it's just a writer's workshop. It's not a conference where people go and present to other people. It's everyone there has a paper, and the other people in their little group have all read their paper, and then they rotate around and discuss each paper, giving feedback. They have this format. It always starts with what they call the fly on the wall, where the writer doesn't talk and just listens.
There was a joke in the
a lot of unusual things.
There was a joke in the chat saying like it's like conference-driven development, but it actually it really was a place for innovation or for new ideas to emerge. And
yes, that's why I emphasized that it was not a regular conference. You know, it was this interaction between different people trying to write things, and some of those things ended up being really great things, and of course, a lot of it didn't go anywhere, right? Like with everything, a tremendous, you know, you have to produce a lot of stuff to get a few things that are going to be. I wrote a lot of stuff I threw away. So anyway, though, to finish the thing about Ralph Johnson, that wasn't even the end of it, because Ralph and those other guys at the University of Illinois who they had this reading group that they read through lots of books together, but they gave me really good feedback. But that wasn't even the end, because then as the book was getting more mature, like I had never published a book, I didn't know what to do. And Ralph gave me advice about like when to approach publishers. Like, I mean, I was pretty well connected by that time, so I didn't have any trouble approaching publishers, but Ralph advised me to wait rather late in the process. He thought that the publishers would influence the book too much, basically, I think, if I got involved with them early. And then when it was, he started pushing me to do things like create an online discussion forum around it, to publish the drafts online, to start building up a community around it and a buzz around it before the book was even finished, so that by the time the book came out, there were already people who had read it, a kind of a knowledge of the book that would already be there when the actual book hit the shelves.
Mm-hmm.
At a time, by the way, when actual physical books hit actual physical shelves. Of course, you just, now I guess I'd say when it appeared on Amazon for purchase. And then that's the equivalent now, right? And then that wasn't even the end, because the first thing that happened then was that, well, that was even before the book was finished too, that conferences, because we had built some awareness of this, conferences were interested, in particular the OOPS conference, which was at the time one of the best, and I did a tutorial there, but I didn't know how to do a conference tutorial. I was like, I can't, make a class about this thing. I've never done that, and I have no idea how. So Ralph did it with me. He was a co-teacher at my first conference tutorial, like the first 2 or 3 that I did. And he said, well, we don't need to prepare a whole lot. We'll just use the patterns. So what we'll do is we'll sit in a big circle, and everyone will just start reading the patterns. And there'll be a little discussion in between, and mostly we'll just read the pattern. So one person will read the problem statement, and the next person will read the solution statement, and then we'll talk. And then the next, and the next, and the next, and we'll see how many patterns we can get through. That was the entire format for my first few tutorials. Yeah, the patterns format actually worked pretty well for me. Although, I think if I were writing something new, I would probably do it a different way. Partly, though, just because I've done that, and I feel like I would want to do it a different way.
So the one lesson for people right now is that if you want to change the world or to contribute something new to the world, the importance of a good mentor or good mentors, or shaping like that community, being community-led or creating communities is paramount. Would you say that?
Absolutely. Good mentoring is so important. And I feel like, I feel that as an obligation on me too, because I got a lot out of mentoring when I was young, and I feel like, that I need to do some of that. Oh, but, I wanted to mention another so that was a very big, Ralph Johnson was very big. It really did help me formulate the book, and then later probably helped the book reach an audience, and also helped me get my head around teaching. Dave Thomas, you mentioned
Dave Thomas,
earlier. Small talk was a very big influence on me, as we already discussed. But I didn't encounter small talk on a job. In fact, it was the other way around. When jobs for small talk started popping up, I was able to say, well, I already have some informal experience with small talk. And that happened because I tried lots of languages, of course, like a lot of people do, just to tinker and experience. One of the ones that I found really fascinating was small talk. So this is the late 80s I'm talking about. But small talk was fascinating, but also mystifying. I just would get confused. I remember thinking, why does anything happen? Because in small talk, you tend to just have a lot of methods that are written as responses to queries. So why does anything actually ever go at all? And so anyway, I think I would have gotten frustrated perhaps and said, well, that was interesting. Now it's time to move on. And but there were online forums, thankfully, and one of them was the one that I used the most, was led by Dave Thomas, who at the time was a professor at well, it was in Ottawa.
Which Dave Thomas, by the way, because there are two, as you know.
Dave.
Big Dave, yeah.
Yeah. I haven't ever actually met the other Dave Thomas. The only one I know at all is Big Dave. But he was incredibly helpful to me. Of course, at the time, I was just one of the people on the forum, asking questions. And he would come back with these very insightful answers, that would take it a level deeper. Not just answer my question, I mean, you know, like it'd be like posting a question on Reddit, and then someone comes back and answers your question, but they don't just answer the question you asked. They answer sort of the question you should have asked, and then they go a little deeper to motivate that. You know.
I know what you mean, because Rebecca helped me for my book as a reviewer, and it was very, very precious. Most people probably think that the biggest domain influencing your book was obviously cargo shipping, but actually it turns out that it was not the only one. And I remember a story that told me a couple of years ago about your early past in chemical kinetics simulations about silicon wafer semiconductors manufacturing or something. Looks like a domain full of complicated words. Can you tell us more about that quickly?
Right. So when we're reflecting on, because we were reflecting like on how I ended up doing things the way I did and where DDD came from, and this idea of what a model is. Because I think that if I had not done this, if I had just come straight into software, the way people talked about software, about modeling in the software world, would have taken me in a slightly different direction. But I didn't come out of that world. Like, you know, I encountered modeling first through physics in undergraduate stuff, and then in my graduate as a chemical engineering, as I mentioned, a master's in that. And I was on this research project in chemical reaction kinetics, which is the study of how fast chemical reactions go and the factors that control the speed of a chemical reaction. So I was involved with that, and I was, of course, a junior on this research project. One of the things that I was assigned to do was to write the software that actually did the calculations, and that was pretty important, because later I realized that the most fun part of all these engineering projects was the programming part. So I ended up steering myself off into the world of programming. But the other thing was that because this was a modeling project, they had a lot of data, and they were working on a model that would allow them to take, you know, different factors. This was in particular for semiconductor manufacturing. So when you create chips, the way it's done is you start with a blank silicon wafer, just a little plate, and then they deposit something on there, and then they put a pattern over that, and they etch away the part they don't want, and they repeat that over and over to build up a complex pattern. So there was an idea, and that sometimes, so you might, for example, have a layer of something and then etch a trench into it. And then, so you might have a layer of some kind of insulator, and then you etch a trench into it, and then you deposit some kind of conductor over the whole surface, and then you cut away the top part, and all you're left with is the part that was in the trench. And so that's how you make a wire. Well, there was the idea that maybe you could fill the trench without all the extra steps. If you could get so in this case, what we wanted to deposit was epitaxial silicon. Silicon, that means silicon in a sort of crystal lattice, as opposed to polysilicon, which is less organized. But never mind that. The point was that you wanted to grow only in the trench and not on the upper surface. Well, that isn't physically possible. You can't get it to just grow in the trench. But what you can do is adjust.
That's what you mean? I try to find pictures for people to understand, because it's very technical.
Pretty good, actually. That picture is good, because what it shows is that things will grow everywhere, and at the bottom of the trench, at the top of the trench, the sides of the trench. What it doesn't show is that as it grows around the corners of the trench, the structure aligns with that, and it distorts the lattice so that if you could get it to grow, you can't get it to grow just in the bottom of the trench, but you can make it grow preferentially there. So we were creating a model, and I was working on this part, and a mathematical description of how it would grow, of the rate at which it would grow under different conditions within the trench. And then, of course, software to solve those equations using numerical methods and things. So I think that this story that you're remembering is that we had a three-dimensional description of the environment of the trench. It was broken into little cells, little cubes, and you could describe, each little cube, what the temperature, pressure, and gas composition was in there. And then you could, by the adjacent cube, you could say, okay, well, this much will come across that wall and so on. And so you can divide a space up that way and describe each one of the cubes using some partial differential equations about how they differ.
Wow. Differential equations. Wow.
Yeah. Well, okay.
So it's modeling.
It was very cool.
It's modeling, right?
Huh?
When you say simulation, we hear modeling. Is that the same thing?
Well, yes, because it was a model. That is, we had a model of how we thought it worked, right? What did we think were the factors? So we would use that model then, which was described in terms of equations, and we'd say, now, does it actually work? So then I had to write the program which solves those equations with a known data set, and we say, look, the result actually matches what I got in the experiments. The rates, the amount of differentiation between the bottom of the trench and the sides of the trench and so on matched what we did in the
experiments.
Other people had done in the experiment. But this was the part that I think, and that was very exciting, and I was very proud of this thing we had done. But then I ran the simulation in different ways, and I noticed something, which was that if you had an extremely long trench, the results were similar to a medium length trench. In other words, the trench didn't have to be very long at all before it was essentially the same as an infinitely long trench. And when you get an infinitely long something or other, it means you have a dimension you don't need. In other words, a two-dimensional model of the trench gave essentially the same result as a three-dimensional model of the trench.
Wow.
And so this was quite a useful insight, but also really discouraging. It was a breakthrough. It did not feel good. And the reason is because this beautiful model that we had created with all those partial differential equations and all that intricate system that I had created to solve those equations could all be replaced by much simpler equations, ones that didn't have all the fancy mathematics. Solving two-dimensional problems is a lot simpler than solving three-dimensional problems.
Yeah. So this story is very edifying because it looks like a lot when we fall in love with our models that are very sophisticated, and we know at some point we found out it could be simpler, but much too simple to be of interest for us selfishly as a reward.
Yeah.
So I mean that's the origin of this. Don't fall in love with your models or something.
Yeah, well, it is probably many things. Don't fall in love with your model. So what did I have to do? I had to take a breath and say, although this model is very impressive, anyone who looks at this is going to be impressed by me. But actually, the problem can be solved just as well with this simpler model that can be programmed rather easily, and it will take a fraction of the computational resources and could be incorporated into more complex, larger models, right? I mean, if you're trying to model an entire chip, then having just one tiny trench be a fairly complex thing is going to hold you back. So it was great. I mean, it was a way better more useful model, but no one would be very impressed by just seeing the final result. And well, I think the people on the project were reasonably impressed because they had seen the whole thing up to that point. But later, someone looking back at it would say, oh yeah, well, that's because that's a simple problem, you know, because you can take a two-dimensional slice of that trench. So the point, yeah, there are many things I learned from that experience that probably influenced me later. The importance of not getting emotional. It isn't that you're not going to get emotionally attached to your models. You will. So it's more of like recognize that and be ready to deal with the pain of throwing away this thing that you are so fond of in favor of either because it doesn't work. I was prepared for that, right? We were all prepared that I would run the program and the results would come out and they wouldn't match the experiment. And of course, then we would have known, well, our model was simply wrong. But in this case, it wasn't wrong. It was just that there was another simpler model that actually gave the same answer or almost the same answer to within experimental. And so, yeah, that was painful. I mean, I knew it was the right thing. I knew that a simpler model was a better model, you know, was a more useful model.
But now we benefit from this.
Expensive.
Now you can warn us. You can warn everyone that yeah, this will happen to you. Be prepared. There are other things. There are other things I hear in this story. I also hear that you just listening to you talking about this chemical kinetics. It's obvious that you've been deep into the domain. You are like a proxy domain expert yourself. So you've been very curious about learning this thing yourself.
Right.
Immerse into it.
Go on.
Yeah,
well,
so I take that as an example of how deep we are supposed to go when we join a new domain, even though we are just supposed to code something for it.
Yeah, I mean, that is an interesting point. I wasn't just a proxy. I was a domain expert. My primary expertise was, you know, I was primarily knowledgeable about the chemical reaction kinetics, not about programming. Programming was like, I did the programming as most engineers do, some programming, and I probably did it really badly. That code is, I don't know, but it's probably terrible. I mean, if I looked at the code now, I probably think it was terrible. But yeah, I wasn't just a proxy domain expert. That was now I wasn't like my professor and the more senior members of the project that I was on. Of course, they were much deeper experts than I was. But that was, if to the extent I was an expert in anything, that was the area. So yeah, when I later got involved in software projects where I was writing software for other people in domains that I didn't really know much about, at first I just followed the path that, you know, the software industry had. So there were all these processes you did. You had an analysis, requirements gathering phase, an analysis phase, and so on. Of course, when I was starting out as a junior programmer, I was just assigned, like, do this, right? Make a button that you click and then this will happen, right? That kind of stuff. Although I was lucky about my early projects and they were a bit deeper than that.
Like everything, agile was a reaction too. All these things, agile was a reaction against or something.
Yeah, see, that's the thing people forget. You know, now we have a reaction against agile. But anyway, to complete the thought about, like, one of the things that happened, I mentioned how knowing Smalltalk was, I got a job doing Smalltalk work when that sort of suddenly exploded on Wall Street. Suddenly I could get a job, even though I didn't have a background as a professional programmer, right? I had this engineering background. But the other thing that helped me get that job was that I had a little financial background. And I won't go into that because we're short on time, but after college, I mean, after I had my bachelor's, but before I went to grad school, I spent a little time focusing on financial work. And that's what my dad did. And I just kind of was thinking, oh, I'll go into business kind of with him. And then that didn't really turn out to be what I really wanted to do. I decided I wanted to do something technical. I went and did the engineering, et cetera. And then the story that I told you happened. But because I did have this background, these, investment banks were very interested in this person who could program small talk and also understood a certain amount about finance. And they said, well, that's bound to be useful to us. So they hired me, and I was able to talk to we were writing software for various participants in this financial activity, investment banking, and including the traders and a few other roles. And I was able to talk to these people sometimes more effectively than some of the other members of the team. And so I had, of course, in this case, I had a little background. But then when I went on to other projects where I didn't have any background, so like, say, you mentioned container shipping, but actually before I was ever involved with cargo shipping, I was much more involved with financial software.
Mm-hmm.
I think I imagined that I would mostly do financial software because I had a knowledge in that area. But then I went into this cargo shipping thing, and I realized I didn't understand what they were talking about. I mean, I know what a ship is and I know what a cargo is, right? But you get very deep and you realize there's a whole complex thing going on here. So I could read the requirements document that someone had come up with and just do what it said, but that was very unsatisfying. So I realized, no, I want to dig in, talk to real domain experts, understand what this is about, not just what they do, but why they do it, and get into their heads a little bit.
Like getting back to the situation where you are comfortable enough with the domain, just like you used to be when you were the expert, basically something.
Yeah, you can kind of see a gradual stepping away from that. I started with actually being the domain expert and being, just an adequate programmer, a barely adequate programmer who's programming in his own domain. And then I was in the finance domain where I actually started down the path of being a finance expert, but I was working in an area that wasn't one that I had ever worked in. So I wasn't a domain expert, but I was the next best thing, right? I was sort of and then stepping further away from that into a domain I knew nothing about and having to learn it completely as an outsider, as a software person, talking to people who really knew their business.
It's extremely pleasing as well, right? As an approach to learn a new domain and get to understand as quickly as possible, as deep as possible. It's extremely rewarding as an approach.
Say that again?
Is it? I think the way I experience it is I find it extremely rewarding. Would you agree on that? And the more you do it, the easier it is.
It is very rewarding, and I think though to do it, you have to cultivate an actual interest in that domain. You can't fake it. You can't just say, okay, I'm going to go through the motions. Your domain is completely boring, but I'm going to now ask you, why do you do this? Because that's what it says to do in DDD. And I don't think that will work. You have to actually be curious about it. And when you get in the conversation with them, you have to, if you're, like I recommended, try to get to the pain points, try to understand like what keeps these people up at night. But if you just say, okay, the next interview question is what keeps you up at night? All right, this is what keeps you up at night.
What keeps you up at night?
Genuinely interested.
Okay, that's very important because from this story of semiconductors manufacturing, we can hear a lot about the curiosity for the domain, about how modeling is not just data modeling, but it's really modeling behaviors and complicated behaviors of deposition of metal oxides on the wafers. So when you say data modeling has nothing to do with domain modeling, indeed, but not everyone has this experience.
No, you didn't. It certainly has something to do with it, but it isn't what I mean by domain model. Yeah, So every time you say something about the kinetics, it's funny. This is the way domain experts are. You didn't say it quite right, like about when you were talking about the, and it's like, no, that's not quite what. But of course, that's not the point. Yes.
Yes. Yeah, we are totally, we run out of time. There was a couple of questions on people asking about the community things. So the usual jokes, I would not ask you the questions that event sourcing is secure, save DDD, microservices, save DDD, event storming, data meshes are going to save DDD again. We don't have time to discuss that, but we know the joke. And actually, probably DDD doesn't need any help after all these years. What about
I don't know. I mean, one of the things I will say is that look at all these topics, most of which would have meant nothing in 2004.
Yeah.
Or very little. They were like exotic technologies then, and they're mainstream now. So we're figuring out how to do DDD with microservices and meshes and all kinds of crazy things that barely existed, if they existed at all, in 2004. That's a really exciting thing. That takes a community to do. You can't.
And still relevant.
Yeah, and then the jokes. I mean, looking back over the evolution of the community, we really have had quite a lot. I mean, I remember when Borats were popping up all over the place, and we had our own DDD Borat.
I was to come to this topic, this mystery, having fun of what we do wrong, having fun of sharing some reverse insights. Do you like this person, this Borat, DDD Borat? How do you think about it?
Of course, I did enjoy the DDD Borat thing, and it's really valuable to have things like that and not take things too seriously.
Mm-hmm.
I mean, and then also to do. There's two kinds of critiques, right? There's the serious critique, which I've tried to do myself, and then there's the kind of court jester humorous critique, which I'm not the right person to do, but someone out there, took up and DDD. Of course, Borats were a big meme at the time, and then so everyone had their Borat. But I think ours was more clever than a lot of them, and it made a lot of really good. There was a list of DDD principles that the DDD Borat came up with once that I thought was really funny. Like the one that comes to mind
fake newspaper thing, a kind of fake newspaper.
Yeah, and one of the things on the list was a ubiquitous language is some kind of coming up with a common language made of terms that no one uses at all. Oh yes, but making fun of the fact that ubiquitous was kind of an unusual word for a lot of people, And
yet jargon everywhere.
Yeah. A lot of jargon trying to say that you are going to use the language familiar to the domain people. It was said much fun. See, now you know why I'm not the DDD Borat. I'm sure a lot of people suspected that it was me, but it was definitely not me.
Yeah, by the way,
and you can tell now because of the mess I made out of trying to convey that one DDD Borat joke.
What everyone wants to know is that who's behind the DDD
I can
Borat?
tell you, I tried for years to figure it out, and I never did. I had concluded, based on my own observations, that it was almost surely a European, because there were lots of tweets related to European conferences and things, and hardly ever anything related to the American conferences. So that much made me pretty convinced it was a European, but I never figured out any more than that.
Mm-hmm.
And
but now you know, or you don't. Can you tell?
Can I tell who? I can't tell you who.
Do you know who's behind?
Huh?
Do you know who's behind? Is it?
Do I know who's
the
behind
mystery?
it?
We've been suspecting Matthias, of course, for years.
I
I
am
don't believe it's Matthias anymore, but
I'm reasonably sure it isn't Matthias. Yes.
so on the chat they say Banksy or maybe Alberto. It's not in the no. It was a usual suspect as well. And if you knew, by the way, if you knew, would you want to share that, or maybe?
Well, I think that would really be up to. If I knew, I would say it would probably not be up to me to say. It would be up to whoever that is. But I can say, I did try. I really tried to figure it out. I remember I was at conferences where we would, in those, those water cooler conversations that you were mentioning. Yeah. Those are very important to design work, but they're also important if you're trying to figure out who DDD Borat is, and you all have your theories, and you're all proposing, well, but DDD Borat tweeted about this conference, and I know that person was not at that conference, and whatever.
Yeah, well, maybe it's best to keep it as a mystery then.
I don't know. As I say, I think that's up to DDD Borat, but yeah, it's like fun mystery in a way. I mean, there's a part of me that always wants to know, but then if you actually did know, would that make it funnier?
No,
I don't think so.
I think as a mystery, it's much more entertaining.
Yeah.
I like it best like that.
And as I think, like Rebecca, I'm not as driven as I used to be. I used to be driven much more, and including driven to figure out who DDD Borat is.
Oh yeah, we want to know. We want to know, but actually, we don't want to know. But we want to know, but we don't want everyone to know. That's the mystery. Anyway, so but let's keep it like that. One more thing, unless anyone has questions on this or reactions on the. I'm sorry, the Miro has gotten totally out of control. We just can't have a look at it anymore. So.
No, that's fine.
Or maybe it's a collective. Maybe Borat is a collective. It's another option that has been mentioned. But it should be a plot with very good coordination, so that nobody spoils the thing, which is kind of very unlikely. we don't know. One thing I'm very privileged to have seen is I've seen you getting upset once in New York City with. Almost nobody. I've seen you like that. And it was when you were modeling with some customer from an airline. It was and during some kind of workshop, the person was not collaborating well. He was sticking to technical discussions, and you wanted to move into the domain, and he didn't want to move there. And I've seen how pushy you can be when you are actually modeling and trying to understand the domain. And I think that's something that I would like to share to the world, that when you want to understand the domain, you can be a different person that you are right now. You really want it.
Well,
what makes you upset these days?
A whole range of human emotions. That is true. And I use them. And yes, of course, when you're really trying to get to the bottom of these things, things can get quite intense. I mean, I tried to convey some of the emotional aspects. Even in the book, I talked about how stressful, or how can feel very unhappy when you make a breakthrough. That's very common, that you feel bad when the breakthrough happens. Mm-hmm. But another thing is, of course, that when you're really drilling in, there's a certain amount of confrontational. There's a confrontational aspect to it occasionally. I think I'm a pretty diplomatic person.
Yeah, you are.
Definitely. Very important. You have to be diplomatic 90% of the time, and you have to always be trying to understand where that person's coming from, what are they thinking. I think that sometimes you encounter a person who either isn't really trying to collaborate with you. That's frustrating. When you know they're not even trying, or occasionally you realize that there's someone who has motives that are not very pure. And in those cases,
never happens. No politics. No. We need your politics at some point.
Rears its head in these situations. And so, of course, in those situations, I mean, DDD doesn't, as such, have any answers to those things, except to say you have to use every skill you've got for interpersonal relationships and recognize that it's really hard to make the kind of collaborative connection that's needed. And sometimes it just doesn't work. Sometimes you're talking to the wrong person, or you're talking to a person who simply won't do it with you. But sometimes it will. And I mean, when you're really in the heat of the moment, sometimes people get a little intense. And that's pretty common in creative work, I think.
Maybe upset was the wrong word. Maybe just
it probably was exactly the right word. But there's all sorts of intensity, and being upset is one. I hope that most of the time when I get that way, it helps to, eventually somehow drive us through. Trying to pretend that everything's okay when it's not isn't always the best, right? I mean, there are times to be gentle and patient. Then there are times to let people know that that's not okay, and that this won't work, and whatever,
And so, modeling a domain is a serious business, and we don't have time for motives.
Yeah.
I think that's a good conclusion. It's serious. It's serious enough so that even diplomacy has some limits.
By the way, I know I haven't mentioned all the influences and mentors and stuff. I feel like that's always one of the things I worry about when I talk about anyone like that, because I know that I haven't talked about them all. And the truth is that there are other people who have been incredibly helpful to me. And so just in general, I'm very appreciative of all those people.
Yeah. I think it's time to close. We are totally over time. Just one more thing, because before I let Matthias take it again, the world needs to know, do you prefer éclair au chocolat or crème brûlée?
Éclair au chocolat. That's an easy one. Why do you ask me these easy questions? Ask me something hard next time. When we next arrange this in 2035.
I'll have to think about them again then. Always a pleasure to be with you, Eric and Matthias.
Same here. Thank you.
Thank you so much for doing this. This was a lot of fun. I hope you had a chance to look at the Miro board. It's a little bit out of control. Everybody who's staying around, bring your food and your drinks and your games, and we can do more open space sessions and everything tonight. And if not, we'll see you tomorrow. We start again at 9 with some lightning talks and at 10 with the labs. So thank you very much, Eric. Thank you, Cyrille. Thank you, everybody. See you tomorrow.